Okay, here we go, continuing on with section P.5 where we're looking at factoring. And the last thing we had left off with was the idea of a difference of squares. When you have a difference of squares, what happens is difference means subtraction, so you have a subtraction in there, and then you have two squared terms. Y squared is a y squared, and 25 is 5 squared. So we have a difference of squares here. Whenever you factor difference of squares, you should still, like every other type of factoring, you should always look first to see if there's something common that you can divide out before you do anything else. As you look at a y squared and a 25, there's nothing common to those that you can divide out. So remember, when you've done that common monomial factoring, the next thing is to try to head for that double parentheses. Now with this double parentheses, remember, at this point, what I can do is, now notice that this front coefficient is a 1, and when the leading coefficient is a 1, you don't need to worry about your box method, you don't need to worry about factoring by grouping, slide, divide, and reduce, or even any of those other methods. A simple little guess and check will be just fine. If you recall with guess and check, that back sign will always tell you whether the signs are the same or different. Now as you notice here, I've only got one sign. So if I only have one sign, then that means that one sign is the back sign. So as I look at this back sign here being a minus, remember that tells me whether the signs are the same or different. And if it's a minus, then they're going to be different. So that means one of these is a plus and one of these is a minus. Now what I'm going to do is take this first term and split it up into the first slots. The only way to split up a y squared is as a y and a y. Then I'm going to take this back term here and I'm going to split it up into the back slots. Now granted, I could split up as a 25 as a 5 and a 5, or I could split it up as a 25 and a 1. But if it splits evenly, like a 5 and a 5, 9 times out of 10, that's what it's going to be. So I'll try that first. Now remember, when you do this, you can check it by FOIL. You don't have to check the full FOIL. All you really need is these outsides and these insides. So on this outside, y times negative 5 will give me a negative 5y. And on the inside, 5 times y will give me a positive 5y. And then what will happen with these? Right, they'll cancel out. And I need them to cancel out because I don't have a middle term right here. So I know that in fact this truly is the right way to factor that difference of squares. Now, if you are one who likes to memorize patterns, the pattern with the difference of squares is, like I said, this is simply a y squared and this is simply a 5 squared. So once I recognize I have a difference of squared, that double parentheses, I will always have opposite signs. The square root of this term will always go in the front slots, and the square root of that term will always go in the back slots. There's the pattern that you can use to memorize, or that you can memorize and use. But if you're like me, and I don't like to memorize more than I have to, the old methods that we used will still work. And you saw that's exactly what I did here. I said this back sign will tell me that these signs are opposites, split that up into the front slots, split that up into the back slots. Knowing that I don't have a middle term, that's my tip, that's my red flag that says, oh, I bet I'm going to split this up evenly into the square roots. So that's how you do a difference of squares. Let's try another one. Let's give a shot with a 36x squared minus a 121y squared. Again, you should always look first to see if there's something common that you can divide out before you do anything else. With a 36 and a 121, there's nothing common because 121 is only divisible by 11, a 121 and a 1, but only divisible by 11. That 11 won't go into a 36. So there's nothing common that I can divide out. So I'm going to head to that double parentheses. And remember, this back sign here, being that it's a minus, tells me that these are going to be opposite signs. Now I'm going to take this first term and split it up into the first slots. Granted, I could split a 36 up as a 36 and a 1, a 3 and a 12. I could split it up as a 9 and a 4, 6 and a 6. But if it splits evenly, I'm going to try that first. Also knowing that this is 2 terms, and 2 terms is kind of a little tip that probably going to split it up evenly. So 6x and 6x. Split up the 121y squared in the back. Y splits up as y squared splits up as a y and a y. 121 splits up as an 11 and 11. Now remember, all I need to check is those outsides and insides. Out here, 6x times negative 11y is a negative 66xy. And inside 11y times 6x is a 66xy. Notice here that these two are going to cancel out. And again, I needed them to because I don't have a middle term right there. So this is in fact the correct way to factor that problem. So that's what happens when you have a difference of squares. Now, difference of squares leads into what we call repeated factorization. And repeated factorization is exactly that. It is repeatedly factoring. And it occurs mostly in fourth degree polynomials. And so, for example, let's say that, factor here. Let's say that I've got an x squared minus a 256. Not an x squared, but an x to the fourth minus a 256. Now what happens with repeated factorization is I'm going to look at this and I'm going to do everything that I did before. In other words, I'm going to look and see if there's something common that I can divide out before I do anything else. There's not. So then I'm going to head for that double parentheses, and I know that this back sign here, it's a minus. That tells me these signs are opposites. One's a plus, one's a minus. I'm going to split this up into the first slots. Now granted, an x to the fourth can split up as an x times an x to the third, but like I've said before, if it splits evenly, 9 times out of 10, that's what's going to happen. So instead I'll split it as an x squared and an x squared. Now this 256, sure, 256 could split up as a 256 and a 1. It could split up as a 2 and a 128. There's lots of other options. However, being that there's no middle term here, just like I saw right there, that's kind of that red flag that says, wow, let's see if I can split this evenly, because what I want to happen is these outsides and insides to cancel. The only way they're going to cancel is like you see right here, where I've got completely the same term, opposite signs. Here's my opposite sign, so I need these numbers to be the same. So in other words, is there a square root of 256? And actually there is. The square root of 256 is 16. So 16 times 16 will give me a 256. Now, with repeated factorization, like I said, you are repeatedly factoring. Technically, back over here, I should have said, well, can I factor this any further? Is there anything more that I can do with this? And there isn't, so I didn't bother. Same thing here, I should have asked, is there something common that I can do? Is there any more factoring that I could do? But there wasn't, so I didn't bother. Same thing here and here. However, if you look at this one, you actually can factor this one right here further. You can split that up into a double parentheses because this is also a difference of squares. Notice that I've got the difference sign right here. That's a squared term and that's a squared term. So what I'm going to do now is I'm going to split that one up into a double parentheses. Again, back sign here telling me these are going to be opposites. I'm going to split this into the front two slots, so it'll be an x and an x. I'm going to split this into the back two slots, so it'll be a 4 and a 4. Check those outsides and insides out. Here I get a negative 4x. In here I get a positive 4x. Sure enough, those will cancel out, and I wanted that to happen because I don't have a middle term. So this one can be taken that way, repeatedly factoring. Now on this one, if I try to repeatedly factor it, what will happen is I'll look at it and I'll say, okay, let's try to set up that double parentheses. This back sign being a positive will tell me, let's make those signs the same. Well, I'm not quite sure what they're going to be. So what a lot of people do is they say, well, let's just make them both pluses. And we'll split this up into the front slots, an x and an x. We'll split this into the back slots, a 4 and a 4. But notice what happens here. When you check those outsides and insides, out here you'll get a 4x. In here you'll get a positive 4x. And a 4x and a 4x is an 8x. But remember, I needed that middle term to cancel because I don't have a middle term. And so that's when we go, oh, that's right. To make things cancel, I need to have opposite signs. So let's just change one of these to a minus. But notice what happens here. Now on my outside I have a negative 4x, inside I have a positive 4x. That's great because they're going to cancel out, and I needed that to happen. But notice what happens when you check in the back. Positive 4 times negative 4 will actually give you a negative 16, but I wanted a positive 16. And that's when a lot of people go, oh yeah, that's right. In order to get a positive, I need same sign. And they say, well, I've already tried both pluses, let's try both minuses. But what happens here is when you check outsides, I get a negative 4x, inside I get a negative 4x. Those actually combine up, and instead of canceling out like I wanted to happen, I get a negative 8x. And in the back, sure, I do get that positive 16 I wanted, but I needed them to cancel. They don't cancel. So what happens is this is what we call a sum of squares. I'll write it down here. And sum of squares never, ever, ever factors. Never factors. So when you see a sum of squares, you're stuck and you cannot take that any further at all. So this one will stay as an x squared plus 16. But yes, you can take your difference of squares and factor it out. So there's the result, and that's completely factored. And again, you can check this, because remember, if you FOIL this, it'll get you back to here. And if you FOIL this, it'll get you back to here. And you need to get all the way back to the beginning. If you can get all the way back to the beginning, you know that it's right. So that's what happens with repeated factorization. Let's try another one, just to get ourselves really good at this. So let's try a 81x to the 4th and minus 16. Now again, when you factor, you should always look first to see if there's something common that you can divide out before you do anything else. There's nothing common to both of these. So I know I'm headed for that double parentheses. I know that this back sign here, because it's a minus, it tells me my signs are opposites. And I'm going to take this, I'm going to split it up into the front slots. 81x to the 4th splits up as a 9x squared and a 9x squared. Again, I could split it up as an 81 and a 1. I could split it up as an x to the 1st and an x to the 3rd. But when there's two terms here, that's my red flag saying let's try to split it evenly. 16 could be an 8 and a 2, 16 and a 1, but I'm going to try to split it evenly into a 4 and a 4. When I check those outsides, I get a negative 36x squared. On the inside, I get a positive 36x squared. Those do, in fact, cancel out like I needed them to because I don't have that middle term. So I know it's good. But remember, you still should always check to see is there more that you can do. Now here, that's that sum of squares we just talked about. So that won't go any further. No matter how hard you try, you'll spend all day trying to factor that thing and won't factor. But a difference of squares will. So I'm going to look at this one. I'm going to say, let's try that double parentheses. Back sign here is a minus. That tells me opposite signs. Split that into the front slots. Could be a 9 and a 1. Could be a 3 and a 3. Let's try the 3 and a 3 because if it'll split evenly, 9 times out of 10, that's what it's going to be. And the 4 splits as a 2 and a 2. Notice here on the outside I get a negative 6x. Inside I get a positive 6x. Those do cancel like I needed them to. And I needed them to because I don't have a middle term. So this is the correct way to factor that. And that's how repeated factorization works. So now let's take a look at the idea of a perfect square trinomial. What happens with perfect square trinomials is we need to do a little bit of a recall here. And what we need to recall is that if I have something that looks like this, you need to remember what it means when you have an a plus b quantity squared. Question is, does that mean distribute the power? Because distribute the power is such an awesome song. We want to sing it over and over and over again. No, actually, it's not because you don't want me singing. So shut me up and tell me no. That's not what this means. It's not distribute the power. Remember, when you take something and square it, it means it times itself. And then when you see this, you immediately know, okay, I'm going to FOIL that. I know it feels like we're kind of taking a little bit of a detour and working backwards, but this is to illustrate a point. When I FOIL this, a times a will be a squared. A times b will be an ab. B times a will be another ab, or ba, whichever way you want to call it, because it's the same thing. B times b will be a b squared. Now remember, I can combine up these two like terms, and when I do, I get an a squared plus a 2ab plus a b squared. This is a perfect square trinomial. It's called a perfect square trinomial for a couple of reasons. One, it's a trinomial. It has 3 terms. 2, the perfect square part is for a couple of reasons. One being that each of these ends, these front term and the last term, are squared terms. Square root of this is a, square root of this is b. The other reason it's called a perfect square trinomial is because it can be factored in this way, creating a binomial squared. So it's a perfect square. Now, If you have an example of a perfect square trinomial that needs to be factored, let's say, for instance, that you've got a, let's see here. Let's say that you've got an x squared plus a 10x plus a 25 that needs to be factored. Now again, you always look first to see if there's something common that you can divide out before you do anything else, but there isn't there. So what I'm going to do is, one method is to say, hey, that's a perfect square trinomial because the square root of this is x, the square root of this is 5, and notice that if I take the 5 and the x and I multiply them together and double it, I get that middle term. That's exactly what happened here. The square root of this is a, the square root of this is b. When I multiply those two together and double it, I get the middle term. When you have a perfect square trinomial, it will always factor this way. In other words, it will always factor as the square root of the first term, right here, will go in the front slot. The square root of the back term will go right here in the back slot, so that square root is 5. Because this is addition right here, remember this will tell me signs are the same, this will tell me they're both pluses, and then I'm just simply going to square it. Now, that is a pattern that you can memorize. However, like I've said before, if you're anything like me, I don't want to memorize too much. So the other option is to go with all of those old methods. And the old methods said, well, let's take a look at this and see if there's anything common we can factor out. There isn't. We'll try to head for that double parentheses. And notice the leading coefficient of 1 makes life pretty easy. Plus, this back sign here will tell me that they're the same. This one will tell me they're both pluses. I'll split this into the first slots as an x and an x. I'll split this into the back slots. Now again, that could be a 25 and a 1, but it also is a 5 and a 5. And when it's this, when you can split it evenly, 9 times out of 10, that's what it is. So I'm going to try the 5 and the 5. Notice that when I check the outsides, I get a 5x. When I check the insides, I get another 5x, and sure enough, those do combine to be the 10x that's in the middle. So here's what I've got. Now in the past, we would stop right there, but it's very, very important, like I illustrated right here, that when you see something times itself, it actually means quantity squared. So I need to write this as the x plus 5 squared. And I know that that seems awfully petty. I know that seems, you're rolling your eyes going, do I really have to do that? And yes, you actually do have to do that. You'll see the reason for it here in about another couple of sections. It's very, very important to be able to recognize when you have something times itself to be able to write it as quantity squared, because it will make processes later a whole lot easier. So that's what happens with perfect square trinomials. Let's try one more. Again, just to get ourselves really good at this. And let's try a 64a squared minus an 80ab plus a 25b squared. Now, like I've said many times, always look first to see if there's something common you can divide out. It looks like it because you can certainly take a 5 out of these, but you can't take a 5 out of this. I can take an 8 out of both of these, but I can't take an 8 out of this. So therefore, there is nothing common that I can divide out of each one of these. I can take A's out of here, but not here. I can take B's out of here, but not here. So again, there's nothing common that I can divide out. So I'm going to head for that double parentheses. Now notice here that, yeah, I do have a situation where the leading coefficient is not a 1, so I could head for slide, divide, and reduce. I could head for factoring by grouping. I could head for the box method. However, guess and check isn't so bad sometimes, especially when, like we said before, this will split evenly as an 8A and an 8A. This will split evenly as a 5B and a 5B. And this back sign here telling me that they're the same, this middle sign here telling me they're both minuses. Oftentimes I will start with guess and check and give it a shot, and if it doesn't work, then I'll toss and grab one of the other methods. So just check your outsides and insides here. Outside 8A times negative 5B is a negative 40AB. And on the inside, negative 5B times 8A is a negative 40AB. And when I combine those two, I get a negative 88B, negative 80AB. That's in fact what I wanted. So I know that this is the correct way to factor it. It's just, I gotta keep my eyes open. Keeping your eyes open means, oh, I see that I've got the same thing here, and when I have the same thing being multiplied together, it means quantity squared. And that's the correct answer for that one. So that's how you factor perfect square trinomials. And like I said, it's the same stuff as before. The only new piece to the puzzle is that when you see something times itself, write it as quantity squared. Now, two more types of factoring that we're going to look at, and one of them is what we call a sum and difference of cubes. Now notice that all the other types of factoring that we've had, I've said that you can do some memorization. You can memorize patterns and you can utilize the patterns, but oftentimes it's not necessary, and I don't memorize all those patterns. I just keep going with the old stuff. The back sign will tell me what the signs here are. Split that into the front slots, split that into the back slots. That always works, especially when you're checking your outsides and your insides. However, sum and difference of cubes is a situation where you do need to memorize the pattern. You cannot get out of memorizing that pattern. It's the only way to do it. But there are ways to make the memorization a whole lot easier. When you have a sum of cubes, notice here I've got two cube terms, and I'm going to put a plus sign between them. That's a sum of cubes. So when you have a difference of cubes, again, you've got two cube terms, and I've got a minus sign between them. The way that you factor sum and difference of cubes, they both handle the same way. They both factor into a binomial and a trinomial. Now, a binomial, recall, has two terms in it, and a trinomial has three terms in it. The easiest thing to do whenever you are factoring sum and difference of cubes, just like with these other types of factorization, I always put my signs in first. That's the easiest thing to do with your sum and difference of cubes as well. The way that you fill in these signs right here, here, and here is by a mnemonic called a cube of soap. Because this is a sum and difference of cubes, so we have a cube of soap, because that's how soap comes, in cubes. The S stands for same, and what that means is whatever this sign is, you carry the very same sign over. The O stands for opposite, and that means whatever this sign is, change it to its opposite. This was a plus, change it to a minus. This was a minus, change it to a plus. The AP goes together, and that means always positive. And that simply means I don't really care what you have over here, this back sign is always going to be a positive. So that fills in the signs for cube of soap. Now what you do is you fill in your slots. Very easy to do. You take a look at each of these. Its cube root you put right here. Then you take a look at each of these, totally ignoring the signs because we've already taken care of all the signs. So you just look at the digits themselves. Cube root of these goes right here. At this point, you totally ignore everything else and you just work with these numbers right here. I'll take these two digits and I'll square them and put them right here. I'll take these two digits, again, ignoring the signs because I've already taken care of all that, just the digits, and square those, that goes in the back. So, square it here, keep that same process. Now in the middle, you just take the two and multiply them together. Again, ignoring the signs because you've already taken care of that. There's how you factor sums and differences of cubes. And again, it's a pattern. You have to memorize the pattern. There is no way out of it. But the cube of soap certainly helps tremendously, and it's just cube root, square it here in the front, square it here in the back, multiply the two in the middle. So it's not that hard to do. Now let me take a couple of examples here for you. So my first example is going to be a z to the third. That's a z. I always put a little line between my z so it doesn't look like a 2. Take my z to the third plus 1. Now, as I look at it, being that it's two terms, I think, oh, maybe that's a difference of squares. But this is not a squared term. However, it is a cube term, and its cube root is going to be a z. And this is also a cube term because the cube root of 1 is just a 1. So what I have here is a sum of, a sum of cubes. With a sum of cubes, I know that I'm going to factor it as a binomial and a trinomial. The easiest thing to do is to fill in all your signs first and then fill in your slots. So remember, that's your cube of soap. S stood for same, so whatever this is, carry it down. O stood for opposite, so whatever this is, change its sign, and AP stands for always positive, make it positive in the back. Now I'm going to fill in my slots. Cube root here goes there, cube root here goes here. Now I totally ignore everything else, just play with these numbers. Square this for the front, square this for the back, and 1 squared is just a 1. Multiply the 2 together for the middle. There we go. That's how you factor your sum of cubes. Now remember, I told you that especially with that repeated factorization, you should always look at this and say, is there anything further that I can do? Can I factor this anymore? And there is not, because the only thing I would be able to do out of that is this would tell me they're the same, this would tell me they're both minuses. Split that into the front slots, a Z and a Z. Split that up into the back slots, but you'll notice that when you FOIL this, outside you get a negative Z, inside you get a negative Z. Those combine to be a negative 2Z, and you needed a negative 1Z. So like I said, with the sum and difference of cubes, fill in that pattern, you're done. You cannot factor it any further at all, and this is it. Now remember, you can always check to make sure that you're right, and the way that you would check this is multiplication. So you would simply FOIL that out, actually extended distributive property, because we have a whole lot more than FOIL here, but notice what happens. When I take a Z times a Z squared, I get a Z to the third. This is my check. When I take that Z times a negative Z, I get a negative Z squared. When I take a Z times a 1, I get a positive Z. And now when I take this 1 and distribute it through here, 1 times anything is itself. So I'm going to get exactly this, Z squared minus Z plus a 1. Now when I combine my like terms, there are no other Z to the thirds. But this negative Z squared and this positive Z squared will cancel each other out. This positive Z and this negative Z will also cancel each other out. And I'm just left with a Z to the third plus 1, which is exactly what I started with. Remember, this is not the answer, this is the check. The answer is your factored form, and you know that it's factored when you have things that are multiplied together. I have a couple of parentheses, right here and right here. Those 2 parentheses are being multiplied together, so that's my factored form. And that's how sum and difference of cubes works. Now let's try one more example, because it can get a little bit more complicated than that, only in the sense that the numbers here can be a little bit more cumbersome. So let's try out a 8x to the third minus a y to the third. Now again, you should always look first to see if there's something common you can divide out before you do anything else. There isn't here. So that means I'm going to head for that, head for the double parentheses, but in this case, I'm noticing, wait a minute, cube, maybe this is a difference of cubes. This, in fact, its cube root is y. This, in fact, its cube root. Now, the cube root of x to the third is x. But the cube root of 8, remember, 2 times 2 is 4, times 1 more 2 is 8. So, in fact, the cube root of 8 is just a 2. This is a difference of cubes. So that tells me I'm headed for a binomial and a trinomial. And remember, with that, it's easiest to fill in the signs first. Fill in the signs with your cube of soap. S means same. Whatever the sign is, carry it down. O means opposite, whatever the sign is, change it, and AP means always positive, so that's going to be a positive back there. Now I'm going to fill in all my slots. Remember, the cube root goes right here, the cube root goes right here. Here's where it gets a little bit tricky. Remember, this one is just simply the square of this. But notice that when I square this, I'm not just squaring the x, I'm also squaring the 2. I'm squaring the entire quantity 2x. When you square a 2x, you have to remember that that means a 2x times another 2x. Notice here when I multiply this, it's not just x times x is x squared, it's also 2 times 2 is 4. That's where most people mess up, is they forget that you need to square the entire quantity 2x. A lot of people will give me a 2x squared here. But just remember, it is the entire quantity squared. Now remember, in the back, I'm going to take this and square it for the back. And then I'm going to multiply the 2 together for the middle. Now a lot of people will say, no, wait a minute, a 2x times a negative y is a negative 2xy. But remember, that's why we fill in our signs first, because then we don't have to worry about the signs. So once I Once I fix this, here's my correct factor form. And as we illustrated down here, when you do the extended distributive property here, it will cancel all kinds of stuff out. You'll get right back here to the x to the third minus y to the third. And keep in mind, even though you should ask to see if there's anything more you can do with this, when you have a sum and difference of cubes, that's the pattern, and it won't go any further. You're stuck with that one at that point. So what we're going to do now is we're going to take everything that we've learned so far, we're going to put it all together and see what happens when you have what I call a little bit of everything. So let's say, for example, that I've got a situation where I'm factoring a 5x to the third minus a 40x squared plus a 60x. Now remember, when you factor, you should always look first to see if there's something common that you can divide out before you do anything else. We just haven't seen that yet. But notice here you certainly can. Every one of these is divisible by 5, plus I can take an x out of every single one of them. So I'm going to write down what I'm dividing out, and inside the parentheses I'm going to write down what's left. When I divide this by 5x, the 5's divide out to be a 1, x to the third divided by x is an x squared. Negative 40 divided by 5 is a negative 8. X squared divided by x is x to the first. 60 divided by 5 is a 12. And x divided by x cancels out to be 1. Now remember, you should always ask yourself, can I go further? Can I take this any further? Well, if I can, it's going to be a double parentheses, because if there was something common that I could take out of each one of these, I would have already done it. So I'm headed for this double parentheses, and what I'm going to do now is I'm going to say, well, there's a leading coefficient of 1 right here. That's really helpful, because that tells me this factorization is going to be pretty easy. Back sign here, it's a plus. That tells me they're the same. This tells me they're both minuses. Split this up into the front slots. That'll be an x and an x. Split this into the back slots, recalling that I want two numbers that will multiply for 12. They're going to add up for an 8 because these sums are the same. That's going to be a 6 and a 2. Check those outsides and insides. Out here I'll get a negative 2x. In here I'll get a negative 6x. Those combine to be the negative 8x that I did want. So if I fully FOIL this, I'll get back to here. And when I distribute the 5x through, I'll get back here to the beginning. I need to get back to the beginning. If I can't, then I know something's wrong here, but this in fact is right. Noticing that there's nothing more I can do with this, there's nothing more that I can do with this. So that's completely factored. All right, one more, and then we're going to take a look at 4 polynomials and what happens with those. Let's try a 28x to the third minus an 84x squared plus a 63x. Now again, always look first to see if there's something common you can divide out before you do anything else. Every one of these is divisible by a 7, and I can take an x out. So what I'm going to do is I'm going to write down in the parentheses what's left when I do that common monomial factoring. 28 divided by 7 is 4. X to the third divided by x is an x squared. 84 divided by x is going to be a negative 12. And x divided by x is going to be a single x. Or sorry, x squared divided by x is a single x. 63 divided by 7 is a 9. And x divided by x is a 1. So remember, there's nothing common here that I can divide out. Or if you're not sure, just take a look and make sure that there isn't anything bigger that you can divide out. And there isn't there. But I'm going to see if it's possible to do a double parentheses with that. Try to factor as much as you possibly can. When you can't factor anymore, you're done. You're stuck. But here, this back sign's telling me that they're the same. This one's telling me they're both minuses. Sure, I could do the box method. I could do the factoring by grouping. I could do slide, divide, and reduce. But I'm noticing that this will split evenly, that will split evenly. So I'm going to give that a shot with guess and check. And if that doesn't work, I'll chuck that and I'll grab one of the other methods. 9 splits up as a 3 and a 3. Check those outsides and insides. Out here, 2x times negative 3 is a negative 6x. Inside, negative 3 times 2 is a negative 6x. Those combine to be a negative 12x, which is exactly what I wanted. So I know, yep, That's right. But remember, keep those eyes open. It's very important that you keep your eyes open, noticing that I've got the same thing here. And when I have the same thing, then I need to write it as quantity squared, keeping that 7x in the front. Because remember, if this is all I have, I'll FOIL it here, but that'll only take me to here, and I need to get all the way back to the beginning. So it's very important to retain that 7x in there. That is completely factored. Okay, so the last thing that we're going to look at now, we've been looking at trinomials, and now what we're going to do is we're going to look at 4 polynomials and how that works. With 4 polynomials, it's a matter of regrouping and rearranging and grouping. Doing 4 polynomials kind of kicks back to that factoring by grouping that we looked at before. There aren't really necessarily any steps to this, so we're just going to dig into the examples immediately. And so let's start off with, say, for instance, a 2xy minus a 6 plus a 4x minus a 3y. Now, like I said, this is kind of based on that factoring by grouping. Remember with factoring by grouping, what happened was we were trying to create a 4 polynomial, because when we had a 4 polynomial, we could pair up the first 2, we could pair up the back 2, trying to create that common binomial. And that's exactly what we're going to do here. Notice that if I pair these up and I pair these up, what's common here is a 2, and I can take that common 2 out. When I do, I'm left with an xy minus 3. But notice there's nothing common here that I can divide out. And if there was, if I could create, like, say, for instance, an xy minus 3 as a common parentheses, I would drag that common parentheses out and I'd write down what's left. But that can't happen here. So maybe if I regroup a little bit, then that would make it work. Because remember, addition is commutative and associative. You can reorder and regroup your terms all that you want. So maybe instead of putting it this way, what if we rearrange them a little bit? And let's say that we put our 2xy with our 4x. And let's say we put that negative 6 with the negative 3y. Now if we group it up that way, then let's pair these up and let's pair these up. Notice that within these, both of them have a 2x in common. So I'm going to drag that common 2x out. When I take it out of here, I'm left with a y. When I divide it out of here, I'm left with a 2. And notice with these 2, I can take a 3 out. Now, watch what happens if I do it this way. If I divide this by 3, a negative 6 divided by 3 is a negative 2. If I divide this by a 3, negative 3 divided by 3 is a negative 1. And remember, my goal is that I want to have these common parentheses here, because if I have common parentheses, I will be able to divide what's common out. But as you look at these 2 parentheses, they're close, but they're not quite the same. This is a positive y, that's a negative y. This is a positive 2, that's a negative 2. But notice that, what if back here, instead of just dragging out a 3, what if I drag out a negative 3? Because see, when I take a negative 6 divided by a negative 3, that's a positive 2. When I take a negative 3 divided by a negative 3, that's a positive y. Now those parentheses are the same, granted a little bit different order, but this is a positive y, that's a positive y. This is a positive 2, that's a positive 2. Now the parentheses are the same. This looks a lot like that factoring by grouping, where we said, okay, when that parentheses is the same, we can take that parentheses out, and we can write down what's left. Take it out of here, I'm left with a 2x. Take it out of here, I'm left with a minus 3. There we go, that's the factored form. And notice that if I FOIL this to check it, a y times a 2x will give me that 2xy. A y times a negative 3 will give me that negative 3y. 2 times a 2x will give me a 4x, and 2 times a negative 3 will give me my negative 6. So it does, in fact, work. So with 4 polynomials, like I said, you just rearrange until you are able to make pairs so that within those pairs you can factor something common out, creating that common binomial. It's very much based on that factoring by grouping. So let's try another example here. I'll just put it right here. Let's try an xy plus a 2x minus a 3y minus a 6. So I'm going to try to pair things up. And when I pair up this way and I pair up this way, notice that within these two, they both have an x in common. When I take that x out, I'm left with a y plus 2. Both of these have that 3 in common. I'm noticing both of them have a negative in common, so maybe I better go ahead and drag out that negative 3. When I divide this by a negative 3, I get a positive y. When I divide this by a negative 3, I get a positive 2. Notice here that they do in fact have the same parentheses. One very funky looking term here, one very funky looking term there, but both of them within those boxes have that y plus 2 in common. So I'll take that common y plus 2 out, write down in the parentheses what's left. Here I'm left with an x, here I'm left with a minus 3. There it is in factored form. And again, when I check it, y times x is yx, y times negative 3 is a negative 3y, 2 times x is a 2x, and 2 times negative 3 is a negative 6. So it does in fact check, and that's the correct factored form. Remembering, factored means things multiplied together. Parentheses times parentheses, those are the two things that are multiplied together. That's how I know that it's in factored form. Now, those were fairly easy and straightforward. I'm going to take a look at a couple of situations with 4 polynomials where it's a little bit more difficult because we have squared terms within those 4 polynomials. Let's take a look, for instance, at a u squared minus a 4v squared minus a 4u plus a 4. Now, if I go with that method that I had done right here, where I'm going to pair things up, then what happens is I'm going to pair up these two, and I'm going to pair up these two. When I pair up these two, there's nothing common that I can divide out. Sure, I can divide a 4 out of here, maybe even a negative 4. But remember, the goal is to create that common binomial that I can't divide out of here. So maybe instead I'll reorder them a little bit and rearrange them. So maybe instead I'll put the u squared and the 4u together. I'll put the 4v squared back here with the 4. And maybe instead I'll pair them up like this. These two together and these two together. Because here I can take a u out, that's nice. Here I can take a negative 4 out, that's nice. But notice that doesn't create the common binomial in the parentheses. So then I go, well, let's try to regroup again. Maybe instead I'll put together u squared plus a 4. Well, that doesn't help because I can't take anything out of there. So I'm looking at this going, I cannot pair anything up. Every pair that I try to make, I can't factor anything common out to create that common binomial that I see right here. So maybe instead of pairing things, maybe I can put together a triple. It's going to feel kind of weird, so bear with me for just a minute as I get this set up. Creating a triple, what if I group up the u squared, the minus 4u, and the 4, and make that a triple? And keep that negative 4v squared in the back. Now the reason I'm doing that is because as I go to factor this, because remember that's exactly what I did here. This was originally an xy plus a 2x. And remember what I did here is I said what's common to these, and I drag that common thing out. I was trying to factor that pair, and I was trying to factor that pair. That's what I did when I said what's common that I can divide out. That's factoring. So as I look at this one and I say, well, can I factor this? Certainly nothing common that I can divide out, definitely. But what if I tried to set up a double parentheses? And within that double parentheses, what if I said this back sign tells me they're positive, or sorry, tells me they're the same. This tells me they're both minuses. I'll split this up into the front slots, a u and a u. I'll split this up into the back slots, a 2 and a 2. And notice here that on the outside I get a negative 2u. On the inside I get another negative 2u. A negative 2u minus a 2u is in fact a negative 4u right there. So this is how you factor that. Now remember I said before, keep your eyes open. I said in a couple of sections you'll see why it's important. Here we are. Notice that I've got a u minus 2 times another u minus 2. That means it's a u minus 2 squared. Now, notice here that this negative 4v squared, I haven't done anything with it, and it doesn't disappear. It's a part of the polynomial. So I need to keep it down there. But when I drag it down in this way, what I have created is a very strange looking, yes, but a difference of squares. Because I have a squared term here and I have a squared term here. So remember, with a difference of squares, what that says is, okay, I can set up a binomial and a binomial. This is going to feel very weird. But with a difference of squares, and I'll put my hand over top of the parentheses so I don't confuse myself. It is just parentheses squared, and it is just this term squared. So I have a difference of squares right here. That back sign tells me these signs are going to be opposites. One's a plus, one's a minus. So a plus here and a minus here. Now me, I'll always do the easy stuff first. Back here, I'm going to split that up into the back slots. 4v squared splits up as a 2v and a 2v. Sure, you can split it up as a 4 and a 1, but probably not. Probably going to be a 2v and a 2v. Here's where it gets weird. Split this up into the front slots, but remember, it's a quantity squared. So I'm going to split it up as the quantity and the quantity. In other words, parentheses and parentheses. So basically, this u minus 2 will go here, and this u minus 2 will go here. Now then, that parentheses is not really necessary because it's just a u minus a 2 plus a 2v. And here it's just a u minus a 2 minus a 2v. That is factored form because you've got a quantity times another quantity. There's your answer. And just like with all the others, you can check that. Remember, all you got to do is that extended distributive property. When I take a u times a u, I get a u squared. When I take a u times a negative 2, I get a negative 2u. When I take a u times a negative 2v, I get a negative 2uv. Send this through. A negative 2 times u is a negative 2u. A negative 2 times a negative 2 is a positive 4. A negative 2 times a negative 2v is a positive 4v. And now send this through. 2v times u is a 2uv. 2v times negative 2 is a negative 4v. And a 2v times a negative 2v is a negative 4v squared. Now when you combine up all those like terms, u squared won't combine with anything. But a negative 2u minus a 2u is going to be a negative 4u. And negative 2uv plus a 2uv cancels out. I've got a 4v here minus a 4v here. Those cancel out. And I've got a plus 4 and I've got a minus 4v squared. Notice that this is exactly what I started with. Well, not exactly, but I have a positive u squared minus 4v squared minus 4v squared minus 4u minus 4u and a plus 4 and a plus 4. So this is in fact the correct way to factor it. So what happens with the 4 polynomials, you definitely want to group things up, try to pair things up if at all possible. But if they won't pair, try to make what I call a triple. When you have the triple factored into a pair of parentheses, and then you've got a quantity squared. And then you can take that as a difference of squared and go with it. So let's try one more just to make ourselves really, really good at this. And this time let's take a look at, we'll have a u squared plus a 2u plus a 1 minus a v squared. Now, like we said before, we're going to try to pair things up, but if you'll notice in these pairs, nothing will factor well, because if we pair up these two, we can take a u out, but we'll be left with a u plus 2. That's not going to help over here. Now, granted, this is a difference of squares, and I could do it as a 1 plus b and a 1 minus b, but there's nothing common to any of that, so that's not going to help. And if I pair up anything differently, pairing up the u squared minus v squared, that's not going to help, because that'll create a u plus v and a u minus v. But then I've grouped up this 1, this 2u, and this 1. That doesn't help at all to create any of these factors. So the red flag to me is when I have a u squared and another term squared with a minus, that's a signal to me, maybe I should make triples out of these. So instead I'm going to triple these up. Notice I don't have to do any rearranging. That's nice. So I'm going to triple these up, and I'm going to try to factor it. There's nothing common to any of these that I can divide out, and I should have started off with asking, is there anything common that I can divide out of all those? And there isn't. So I'm going to triple them up, head for that double parentheses. Back sign here tells me they're the same. This tells me they're both pluses. Split this into the front slots as a u and a u. Split this into the back slots as a 1 and a 1. Notice when I check the outsides, I get a 1u. Insides, I get a 1u. That 1u and the other 1u is a 2u, which is exactly what I needed. So that is factored correctly, but keep those eyes open. I have a quantity squared So I'm gonna write it as quantity squared, because it's it times itself. When it's it times itself, it's quantity squared. Don't forget this minus v squared, it's very important. And now I have a very odd looking difference of squares. So when I have a difference of squares, I'm gonna set up my double parentheses. This will tell me my signs are different. One's a plus, one's a minus. Split this into the back slots because it's easy, a v and a v. Split this into the front slots, keeping in mind that this is just a quantity squared. So it's square root, the quantity itself will go inside the parentheses here in the front slots. And remember, it's just a u plus a 1 plus a v, so I really don't need that parentheses that's in there. And the same thing here, it's just a u plus a 1 minus a v, so I don't really need that parentheses that's in there either. Here I've got a parentheses times a parentheses, so therefore it's factored. And that is how you factor for polynomials. Rearrange and regroup, try to pair things up. If you can't pair them up, create a triple. When you have the triple, factor with a double parentheses and aim for that difference of squares. So that's everything out of section P5. This is how you do all the different types of factoring, and I'll see you next time.